Love it, everybody. Love it. Hey, welcome to the rabbit hole. Yeah, the fan favorite rabbit hole, of course. And let me get old Canuck involved on this. Oh, man, was that fun. Yes, sir. Yes, sir. Well,
Quite the
yeah,
intro.
it's quite the intro, right? Oh, I love it, man. Hey, buddy, how are you? How are you? How are you? I don't know.
I'm good.
I didn't get my camera working yet, but it's loud. Oh, it
Yeah,
is. Oh no, it was loud. It's good enough, eh?
nice and loud.
Yeah, man. It's something I just had done, and it says it in 3 minutes. It says it all. Joe Canuck and Luke. Luke's not here at the moment, but he's out there doing his thing. Um, he's been working his butt off, so he's a bit tired. He's got to eat some supper and maybe relax a little bit. But if he's around, he'll be around. Can't blame the boy for dealing with it all. Anyway, how's been your week so far, there, Canuck
Good. It's
or
warming up
Canuck?
here. Here it was like 85 today.
Oh yeah. Wow. We've got lightning and thunder here, so I know that's moving eastward. So yeah, I don't know what the heck here.
Well, we were supposed to get something tomorrow, but then it's supposed to rain again on Saturday. So every weekend since March, it's rained here.
You've been getting rain every weekend?
Yeah, since March. That's what they were talking about today on the radio. So it rains on everybody's weekend. At least it's consistent.
You gotta plug something in there. There we go.
But at least since it's doing that, there's no wildfires here because it rains a lot.
All right. Let me see. I turn that on. It's always, complicated to put on a show pretty good sometimes. But I'm trying. Here. Tonight's subject. There has been. It's not the only time this occurrence has happened. In the U.S. Stanley, Idaho. Those fires are causing quite the haze. Oh yeah, up there in Canada, you're referring to?
Yeah.
No, let me turn that back on.
Well, it's here too until it rains tomorrow. But it's up way high, so you can't smell it. But it makes everything all
right.
hazy.
All right.
You can see it on the firesmoke.ca site because it
shows. Oh, that's that other one, yeah. Hold on a second. The remote control is not here.
Because it shows how it goes all the way across the U.S. and everything too. On firesmoke.ca, it shows all of North America.
Yeah, you think I'd get more professional, be doing this thing for so many years, But I get better at it as I get older, I guess, right? We just had a big deal with my pops. He was. All right, so maybe I do the switcherini here. There we go. All right. I don't know what the standard image. I mean, it's really just hazy image. What are we at? 60 hertz. Temperature, image. 700K. White balance is all right. Hey, all that's good, but more. I don't know. Oh no, I have to turn on the what is that's called the virtual camera, right? All right, so now over here I've got to do the virtual camera.
fire smoke one on here.
There we go. Wow, that's way bigger on that thing.
On this computer.
Hold on here. Oh, poopity poop. I want to see my pecker. Don't get on you, man. I don't know what the hell the camera's doing, man.
Yeah.
I don't know. I don't know. Here. There's kind of delay. So bear with me here. What the heck? All right. Why don't we just... Okay, I know which one it is. No video right now. Let me fix that. Anyway, so what's been happening over the last 2 weeks in Stanley?
It's been busy with a bunch of little quakes.
Yeah.
No big ones so far. But we'll see.
How long ago was that big one in Stanley? 1 year, 2 years, 3 ago? It was like
2020.
Was it already 2020? 6.5, yeah. Ever since then, it's like they didn't think there'd be quakes up there. So,
but it's had quakes in that same spot many times before. It's just people aren't paying attention.
Is that what it is? All right.
Yeah, because I found out it had 2 6s there before. In 1944 and 45, right before all the crazy quakes in Vancouver and Puget Sound, 46.
All right.
But we'll talk about that when we get to it.
All right, sure.
That's just
did this. Oh, you can read it. If I do this, you can read the angels. All right. I got to make sure my angels is on there, man. There you go. You can read it now. A bit of a delay, but... All right, so you've got 2 TVs in the background there. If you don't mind, the one over your left shoulder.
I'll just move it to block it.
Well, you got a basketball game going on, or hockey.
Yeah, the Stanley Cup game's on one.
What? Stanley Cup already?
Yeah, Florida at Edmonton, same as last year.
I don't even watch. Oh, all right.
Panthers.
Well, all righty then. All right, so my sound is good. Your sound is good. I take it Luke's going to be not on tonight, so he'll be on if he wants. He's got the link in his chat if he wants. And all right, so put the first link in there for us, and I think 20 the 6.5 is probably where we should start, I think.
Yeah, the map
that
I'm going to put in first shows all that. So.
Right on. All right.
But I'm going to give the fire smoke link first.
Yeah, we'll try to keep these things going for you on Rumble and out there on YouTube. So there we go. 5x5. Okay, good. Come click. What the frack? Okay. Clicked it twice.
Do it.
All right. Okay, I see the fire thing. Is that what you want?
Yeah, because we just talked about that, about fires first. We'll do a little update on that.
All right.
The smoke going on.
All right. Okay. I got to get over to here. And I got to share that screen. Window. This one here. All right. Now I got to go back and go to here. Okay, boy, it took a minute for it to come up. Show on screen. There we go. All right. Let me send this one. All right, so I'm going to put this over here where I can see it. All right. All right, so talk to me there, buddy.
Yeah, and so this one shows like where the big smoke plumes are coming from the fire, which way it's blowing. And then it tries to guess for so many hours or whatever which way it's going to blow.
Anticipates, yeah.
Yeah.
So if I did the firms right here, let me show them what's going on here real briefly. You can see across North,
Yeah,
you see across Canada,
yeah,
the
it's
main
going
fires.
across the north, basically.
Hey, Dub, how are you, my brother? You can
Basically,
see those are the
in
main
a
fires.
east-west line, pretty much matching up where the Gibbs fracture zone 6.9 was, because there's fires in Newfoundland and Labrador too along the same
right.
east-west line going across. And one of the lineaments we talk about tonight is cutting right through those fires in Saskatchewan and Manitoba, and there's fires on either side of the lineament, but not where the lineament is. It's wild stuff, but we'll see that later when I talk about them.
All right, so we're talking about Stanley, Idaho today, and its connection to the Cascades, its connection to San Francisco, its connection to New Madrid, and as being a part of the greater North America, the movement of the North American plate virtually westward, and the history of it a little bit. And also, he's going to bring in some lineament talk. It's basically electromagnetic lineaments that traverse the globe, and they emanate from the core of our planet and kind of like a slice goes straight up along a generalized direction. And when the planet is charged, meaning the not the asthenosphere, but it could be, but the atmosphere of our planet, it connects all the way down to the core, and the core responds. And it's my supposition that I put out here this week that I think the core in its response emanates bubbles, so to speak, and we call them hotspots across the planet. And these bubbles, as they rise to the surface, they create waves and frequency waves as well as physical waves as it rises up. And that's where volcanoes get activated, and because that pressure has to get through the crust. The stuff that's below the crust that we all live on as human beings and animals and plants, what's down below is like burning hot plasma. Then it goes into kind of a gobbledygook of material. I don't even know what to call it. Molted rock at another level. And then as it cools, it's the stuff that we call dirt and rocks and human beings and animals and whatever. Then atmosphere goes beyond that. We're all part of a system. We can't take one system and say that this is how how it acts. It's interrelationship that we have with everything around us and our planet, whether it's not just our planet, but our solar system, and then the Milky Way, and then all of the other systems out there. We're all part of a giant system. Understanding how that system works is what we do primarily on Rabbit Hole. Try to put it in perspective. The morning reports is kind of just to give you a gist of what's happening that day and in the last 12 hours or so. And sometimes there's an evening report. But what we're trying to do is give you a clearer picture that earthquakes don't happen in a vacuum. It means they don't just all of a sudden happen for no reason. There's a reason behind it. Plate tectonics is part of it. Electromagnetic lineaments is another part. And weaknesses in the plate or weaknesses in the crust and the movement of the crust and the push and pull of each plate and the electromagnetic pulses that permeate our atmosphere and our bodies and our planet itself, and the interplay from our solar system, our sun, and our core of our own planet, all being put together, and that's kind of what we do here. Is there anything you'd like to add to that? Is that semi pretty clear to you, Ganat?
Yeah,
Can
that's
Nuck?
good. Now
All
we're
right.
just going to jump into the Idaho stuff.
Yeah.
From there.
So he's going to talk about this image here that we're talking about in relation to everything else. So we just wanted to bring this up. Look at the fires. Whoa, the smoke and how it's moving.
Yeah, sounds crazy. Now there's not any big fires in Idaho yet, but
Yeah.
we'll see what happens as the summer goes along.
Yeah. Seems to be 5 fires so far, but they're not big.
Yeah. So not anything crazy yet.
Right.
But we'll see if those liniment lines light up though.
Right. All right.
So
So here we have the image of the Stanley, Idaho.
Yeah.
This is shortly after Ridgecrest. Ridgecrest happened in 2019, July 4th. And July 3rd was a 6 point something. I don't know, 6.5 or 6.7. And then the 7.1 happened on July 4th. Later in that evening, I think it was. And then this one happened the following year.
Yeah, right before this one, you had the Salt Lake City.
Utah. Yeah, Utah popped. Yeah.
Yeah, which is on the same liniment line if you keep going.
Yeah. And we'll bring that up as soon as we establish the what Canuck has been studying about this.
Yeah. So now we're just going to do it with the Idaho quakes.
All right.
So the 2 biggest quakes in Idaho that they know about were the one in 2020, the 6.5, and the 7.3 bore a peak one over here in 1983, which is the next valley over, where the Lost River Fault is.
Mm-hmm.
So we're going to talk about each one of those. But when I was looking at this, it had other 6s on this map that I never knew about before. 1940,
1944, and 1945. Yeah.
Yeah. So there were 6s in that area in 45 and 44. So almost in the same spot that the swarm's happening right now. So this area has had 6s pretty recently. So I didn't realize that those 2 happened right before, because we talked about 1946 and the big Vancouver Island quake, 7.3, and then 6.3 in the Puget Sound that same year, both in 46. So Idaho was shaken with 6s the year before.
Right, in 44 and 45, yeah.
Yeah, before the crazy stuff started happening in Puget Sound and on Vancouver Island. So that was the first thing I noticed about those 6s. Well, then I said I'm going to start digging to see what else I can find, because that's kind of what I do. So I wanted to find a list of all the earthquakes that were notable enough that they had like articles on them and stuff, or they studied them, which their focus, of course, is on the 2021 because it's the most recent. So
correct, and it's one of the larger earthquakes too, 6.5.
Yeah, and the 1983 one.
Yeah, the 1983 7.3. That I don't remember that one. I think Kitty Cat would probably remember that one. She's not on right now.
Yeah, and it was the same year as the Coalinga quake. So that's pretty interesting too.
Hey, Coalinga came up the last rabbit hole.
Yeah, I know, because see, all this stuff is all tying together.
Yeah, well, we're establishing that, buddy.
Yeah, so it's pretty interesting. So that big one happened the same year that Coalinga did. So that's like down by the San Andreas.
Mm-hmm.
And once we dig into this farther, you're going to find out that
we just had a near the Coalinga, a little bit south of the Coalinga. We had a 5.2, and they call it Tajon Pass earthquake this last year.
Yeah.
And now we're still seeing vibrations up here at right now a swarm. Classified as a swarm is 10 earthquakes in a given area over a short period of time. And there's been more than that.
Yeah,
might as well be Parkfield. You're right, Dub Beazle. Might as well be Parkfield.
Yeah, basically.
Yeah, and that is a northeast to southwest line And I'm sure you're going to tell me what liniment that might be.
Yeah, we're going to talk about that a little bit later.
The
but
crisscross.
you gotta-
Yeah, that's okay.
Yeah, you got to remember too, we're pretty close to the western Idaho shear zone, which is the old boundary of North America.
Mm.
'Cause I
Yeah,
just thought-
that's interesting too. So
the old boundary in North America shakes before the new boundary of North America shakes, if you want to simplify it.
well, yeah, I mean the upbuilding of the Sawtooth Mountains and the basically the mountain range in the middle of the United States, it's still building then. So a connection to Utah and Salt Lake, you can kind of see that then, because that's the inside track. And then, wow, there you go. We need a bigger picture to see. Let me see if I can give you a USGS
It's
kind
going to
of
start
look.
making sense because once I explain the lineaments, see, we had this one in 2020. Well, then we had the quakes off Vancouver Island that same year. And
You'll
then
see
we had
what's going on here. This is
first
the
Sandpoint quake in 2020. And then we had the two other big ones, Sandpoint ones, in 2021. So if you go up the line from this, bigger quakes all along that line. And it did the same thing in 2017 too, because there was a 5 near Chalice, Idaho. And then we had all those
that's just the
off Vancouver Island. So
right. That goes through Spokane. You have some up in Canada. You not quite as far up as Prince George, but you have some volcanoes up there too, don't you? And nobody really talks about.
Yeah.
And that's on that same kind of
more than one limit line, but we're only going to focus on like two.
Sure, I got you. Yeah. So let's not confuse it a little bit here. Turn that off.
So you can see what it's doing. And now when
so here's Puget Sound up here.
There to 2020, wasn't there the quakes in NorCal too? In 2021.
Well, we'll look that up here.
There's
sixes. Okay. All right. So search the catalog.
I'm pretty sure.
We'll custom. We'll go 6. We'll go custom, and we'll go 2019 just to catch it. And custom, and we'll do this. Come on. There we go. We'll just do the Western United States. Use that region and then search. So it's 6 and above.
Yeah.
Ooh, there's quite a bit of them.
Yeah, we'll get too many.
Yeah. There's the Stanley, Idaho 6.5 that took place. All up and down the San Andreas was rocking and rolling.
Yeah.
Even in Baja, Mexico. Then there's that funky one that took off. Yeah, everybody was tripping about that 6 that happened in the Pacific Ocean.
Yeah.
That's a strange earthquake way out there.
Yeah. So what'd you put in? Did you start 2019?
Yeah, 2019. Yeah, in May. Then you see the 7.0 Mendocino that happened in 24.
Yeah.
Also 6.2 Petrolia in 21. 6.4 in 22 of December.
Yeah.
So and then you have Ridgecrest and you got Monte Cristo at 2020 in May had a 6.5. And Antelope Valley in 21 had a 6.
Yeah.
And that was actually in Walker, the town of Walker. They call it Antelope Valley. It's a different Antelope Valley, not the normal California one.
Well,
it is California.
They're right all on the Texas liniment.
Correct. These two are. Yeah.
And then the one that's coming the other way is the one that goes through Idaho, the northeast to southwest one going to Mendocino is
the
Great Falls tectonic zone. So that's one of the ones we're going to talk about tonight.
So Great Falls goes that way. Texas liniment comes off the Blanco, comes out to Corpus Christi, jumps out to Port-au-Prince and Cuba, not Cuba, but Puerto Rico, and out the islands. So the crisscrossing of these lineaments, the one lineament is moving on up into the Port McNeil 6.3 that happened in 2019.
Yeah. See,
Also another
although
26.0.
The owl out Olympic Walla Walla
Yeah.
limit, that's exactly where it goes.
Right. And Port McNeil 6.2 in 2019. So all these 6.5, this is the last one, 6.5 in 2024 on September 15th. These other ones happened in 2019, and this one in 2020 happened. And the owl, the Olympic Walla Walla lineament, basically runs down this little.
It goes right through Seattle and goes right by Nick's house.
Right.
And keeps going right down into the corner.
And it goes right into this, whatever this anomaly of volcanic something in there, but right through Yakima right here.
Yellowstone too. And if you keep going with it, it goes through Salt Lake City. It goes through Wichita, Kansas, and you keep going, it goes past New Madrid. And you keep going, it goes through northern Florida, cuts down across Florida, and goes to Puerto Rico.
It's not in a straight line, but it's in a line.
Like a 2D map.
And they're wide too. These lineaments sometimes are included with lesser lineaments. And sometimes they're 50 miles wide, sometimes they're 500 miles wide, depending on how active that lineament is.
How much
that can affect that. Yeah, it can affect that area as wavelengths move along paths, such as electricity moving along a wire. It's not in the wire; it's around the wire that the electricity travels along, and that's the same thing with these lineaments. They're reoccurring along these lines over and over and over and again. I think modern science is starting to catch up to the idea, and it's interesting that they're now, like I said, starting to catch up on it. But anyway, what did you want to say about the connection between Idaho and up there in Canada? I think you were saying something interesting about that.
Yeah, well, it keeps going there through those quakes that are on the screen right now, right up through Vancouver Island. And if you keep going on that same line, it goes right up past Kodiak.
Yeah, and Kodiak was busy here.
And those same years, 2020 and 2021 is when we had all the Sandpoint quakes, which are on the other side of Kodiak Island. So if you extend Texas limit, all these quakes are happening between Owl and the Texas limit, pretty much.
Right. So
straight out.
So if I were to go like this and took a picture and just said okay here, and I'll save this to my desktop. You said Kodiak Island is right here. Sandpoint, right? I don't know where Sandpoint is. I think it's right.
Yeah, it's just down
right here. Sandpoint.
Sandpoint.
So Sandpoint had the last 8.2.
Yeah.
Right. That's the last 8 that we've had.
Yeah.
July 7th. Wow. That's crazy, dude.
Yeah. See, it's all close together in the time periods.
Yeah.
And I found now that I had the list of every felt quake in Idaho that has been felt there since 1872. I just started looking up all the numbers, and I can see that it's going off before big quakes in Alaska. And I found one going back that I think it was in the 60s. Sandpoint went off with a smaller one, 0.6. So it was doing all the same thing back then too. So
and we were studying last week the volcano that's off the coast of Oregon and Washington there, and the names of these volcanoes in the water or under the sea, and that they do follow a pattern 1,000 miles in difference, whereas
And
they
those
all initiated.
the
Go
seamounts
ahead.
are on the lineaments.
Yeah, and this particular seamount off the coast of Oregon here, there are rocks or volcanoes that are up here 1,000 miles away that originated here. So the hot spot that exists here is along this same kind of traverse of the Texas lineament and the Owl, which you can move all the way up into here, which is Kodiak and Sandpoint, right in between here. And so this is the area that's been very active over this short period of time, geologic time, of course. And that's kind of what he is saying, that there's something going on.
Man's out here again. Okay.
And it's a repetitive process that happens. And we're just trying to describe it to you the best we can.
Yeah. So what I'm going to do next, because I want to talk about the 2020 quake and the 1983 quake.
Okay.
2020 first. I'll bring it up. And it's going to be good because the stuff they have in the wiki like ties into the other things we've been talking about already.
Okay. I've got it from USGS, so you can just read the wiki.
Yep. So this is the one that was in 2020.
The tectonic summary of the 2020 from USGS is the 6.5 earthquake was in west of the Chalice, Idaho, occurred as a result of complex strike slip faulting within the shallow crust of the North American plate. Preliminary focal mechanism solutions for the event, which describe the style of faulting in the earthquake, indicate a slip likely occurred on the steeply dipping fault striking either east-west, right lateral, or north-south, left lateral. This earthquake occurred within the intermontane seismic belt, a prominent zone of recorded seismicity in the intermontane west, and is within the western part of the central or continental tectonic belt, an area southwest northeast extension north of the Snake River Plain. The quake is about 16 kilometers northeast of the Sawtooth Fault, a 60-kilometer long normal fault that extends along the northeastern base of the Sawtooth Range. Historic seismicity in the immediate vicinity, March 31st earthquake is sparse. No earthquakes of magnitude 5 have occurred within 50 kilometers of this event over the past 50 years. And the most notable historic seismicity in the region occurred 100 kilometers to the east on the Lost River Fault Zone. This was the site of the 1983 6.9 Bora Peak earthquake that happened in October 28th, which was followed by 5 other magnitude 5 events over the following year. The most recently magnitude 5 earthquake on January 15 of 2015, I should say, about 60 kilometers to the east of today's event. The March 31st, 2020 event is the largest in Idaho since the Bora Peak earthquake. That event killed 2 in Chalice and resulted in $12 million in damage in the Chalice-Mackay area. As of 1 hour after this earthquake, 2 aftershocks for 636 have been located by the USGS, both south of the 6.5 event. So that's the
same area where it's swarming right now.
Correct. Yeah, very, very interesting. And we watched. I remember us watching here on during the morning report. Also, in several of the other updates that we did, or reports that we did. Report happens and then an update after that. We were watching a lot of earthquakes happen along the Sawtooth and east of this particular event. And it was my understanding that this is the most Western earthquake of any significance that has happened, and they did not believe that this area would do this much or this size of an earthquake.
Yeah, but they figured out now since 2010 with LIDAR and other studies on the Sawtooth Fault right before it can make a 7.5.
Wow.
Yeah. So if you read the current studies on the Sawtooth Fault, that's what they say.
Wow,
so this area below it can go mid-7, a little bit below it.
Well, they did have the one in 83, right? That was a 7.
Yeah, they say 6.9 to 7.3. If you look at the Temblor map there I had up before, they called it 7.3. So they think it was pretty big, which is like the next valley over on the Lost River Fault.
Well, I felt the difference between a 7, a 7.1, and a 7.3. And a 7.3 is exponentially stronger than a 7. I mean, exponentially. So
well, we're gonna read about the 83 quake next.
Okay. So go ahead, and you have the wiki up there. It's shared in on Twitch, but we'll try to keep those people who are in Rumble and on YouTube in the loop.
Yeah, so I'm putting the 1983 one in there now because it's pretty cool to read that too. So it was even bigger than.
Yeah, in the wiki, it's the 2020 Central Idaho earthquake, and now this other one is the wiki 1983 Bora Peak earthquake. Yeah. So let's. Did you finish? Did I jump the gun on you there on this one?
Right. I wanted to go to that one next anyway.
Okay.
Because it ties into what we're talking about.
All right. Here's the Bora Peak. Go ahead.
Yeah, the 1983 Bora Peak earthquake occurred on October 28th at 8:06:09 a.m. Mountain Daylight Time in the western United States in the Lost River Range at Bora Peak in central Idaho. The shock measured 6.9 on the moment magnitude scale and had a maximum Mercalli intensity of 9. Violent. It was the most violent earthquake in the lower 48 states in over 24 years since the 1959 Hebgen Lake earthquake in nearby southwestern Montana. So if you keep going on that same line, northwest to southeast, it takes you right to Hebgen Lake.
Yeah, okay. Yeah. Not at a steep angle, but
yeah, like at the same angles what Al is. Because Al is not like super steep. You'll see when we do the maps.
Basically, the Al follows this highway right through here between Wenatchee and Yakima. It's right in the middle. Mount Rainier's to the south, and the like. Up in the north is Baker, and so it's between Mount Baker and Mount Rainier. Often, as a side note, I've seen the traverse of earthquakes come out of Vancouver area and migrate between Rainier and a Baker. And depending on what side of Rainier it went, the pressure went south. And if it was closer to Baker, it kind of went interiorly, and that would go through Idaho and Utah. I've seen that happen on and on and on again. So just to kind of keep you abreast when you're watching earthquakes, it's like, hey, also this 83 earthquake happened, 4 years before the Whittier in Los Angeles. So it's really close, but not quite close enough.
And when we do the 84, 85, 86, 87, 88, you'll see that there's big quakes the whole way up that from Vancouver Island up through Gulf of Alaska, all the way into South Alaska in the years following Bora Peak.
Wow.
We've already talked about them before because they were the lead up to the San Fran quake in 89, because there's 2 large quakes in Gulf of Alaska, 2 7s.
Right.
Up here. I think it was 86, 87. Then Yellowstone broke out in massive wildfires the summer before the San Fran quake in '88, and they didn't know why all the fires started because all the tourists had to run.
And to run for their lives.
Yeah, in '88, the Yellowstone wildfires. So it's pretty interesting because I started when I looking up this stuff before. I kept just adding more stuff to it. Now I'm finding more things because I wasn't paying
Well,
attention.
you're several disciplines crisscrossing over. That's why we started with the fires. Often in California, they would say the chaparral or a specific plant would self-combust. That was their explanation for a lot of things. And that desert area is all throughout the West, including Idaho, Wyoming, and Nevada, Utah. So the same kind of plants, and we're talking about the greater basin and range system or a location. And I find that interesting too, that rocks themselves, you push them up hard enough, they can spark. And what is it? Serpentinite or whatever. I think some people believe lead to starting fires as well. I think they follow the serpentinite traverses. I've heard that too. So the reason you bring it up fire is because it's uncanny that these fires happen along a certain trend, a trend line or a lineament. And it's like, hey, why didn't they start over there or over there? But they're starting along this line. It's like, hey, it's like the earth is telling us something. Hey, there's going to be an earthquake here, guys.
And they done it long before we were paying attention to it.
Right. And sometimes it gets blamed on fracking or oil drilling or just, homeless people or whatever. Sometimes these events are weather. It's like, wow, what is going on?
And I looked them up so many times because what I do, I watch and see how the fires start and what line they're going. Then I look in the fault maps and they always match. So like when all the fires started in Quebec and everybody was watching on satellite a few years ago, back 2 or 3 years ago, they all started in northeast to southwest lines simultaneously. So if that was happening, the arsonists had to be all setting them in Quebec out in the middle of nowhere.
Right.
Multiple space lasers all shooting at the same time in straight lines that just happen to be on the fault lines where all the mines are in Quebec. Well, when there was a big fire in Nova Scotia, I looked up the same thing. I found out where the fire started in Nova Scotia here a couple of years ago. They were all along where the old mines where they used to go for quartz and gold back in the 1800s in Nova Scotia.
And so, what do they find with that?
See it. And then I went to northwest Alberta when the fires were up there the last couple of years, and it's the same thing. The faults there are northeast to southwest in that northwest corner of Alberta through Peace River and all those places, and the fires started all along those same lines. And this is what it does every time. All I have to do is watch the satellite of how the fires start and see where they are, where they initiate. Then I look up the fault lines that are for that area, and you'll find they always match up. So it's a magic. Not really, but that's how it works. So that's what it's doing. So once you start understanding the fault lines, where they are, then you can also see the lineaments because you can see how the fault lines are orientated, and sometimes they cross over each other. So when it does that, it's lineaments that are crossing over each other. So the fault are identify the lineaments because the lineaments make the faults.
Well, you made a comment about the types of rock that you said, and the serpentinite is a metamorphic rock composed predominantly of serpentine group materials formed by serpentinization of mafic or ultramafic rocks. The origin of these names are uncertain, but it doesn't really matter. Most of the chemical reactions.
And if you read all the current stuff on faults, the farther they drill into the fault, doesn't matter which one it is, San Andreas, New Madrid, anywhere, the farther they drill into it, they find more serpentinite.
Correct. And that's why I brought it up. Most of the chemical reactions necessary to synthesize is acetyl CoA, or essential basic biochemical pathways of life, take place during serpentinization. Serpentinite thermal vents are therefore considered a candidate for the origins of life here on this planet. And you know that underwater volcanoes, you see all kinds of life, even the greatest depths. They're like, I can't believe life is down here. Because, we're born. Serpentinite is formed of mafic rock of hydrated by carbon dioxide deficient seawater that is pressed into a rock at great depths below the ocean floor. That means below the water, okay, everybody? It occurs in mid-ocean ridges and forearc mantle and subduction zones. That means it's way down there. And when serpentinite comes to the surface during these faults, go ahead.
And if you read the current studies that they have now, which there's a whole bunch out there, there's one that just came out. It talks about the serpentinite rocks down in the fault are what initiates the quake, because it changes its chemical composition. And that's the new thing they're talking about in all the new studies, the fluid pore pressure.
Yeah, the fluid pore pressure.
It becomes more liquid, and that's when the quake initiates, and you hear all the rocks breaking. That's what it's doing.
Yeah. When water boils, it turns into a gas, right? And that gas gets hot enough, it starts to melt rock. And as it does, it melts the rock. The rock shears, snaps, and cracks, and then turns into magma. And then that magma begins to rise to the surface. And that's another way magma rises, not just volcanically.
And this process, they say, is what's causing all the piezoelectric stuff and heat and gas. And
correct.
So all these things that are happening, which I say is probably what's causing the majority of the wildfires. Because they always start in a ravine or a canyon or someplace like that if nobody's there. So it's crazy stuff. But anyway, we're off on a tangent.
We're talking about the fires, and this is why it's important to understand how does the fires relate to the earthquake? Well, the fires relate to the earthquake. It's a possibility that these rocks, not that they self-combust, but the minerals, kind of like flint, right, spark and get hot enough, and then what's super dry, right?
Yeah, catches. You still need it to be super dry and windy for it to do anything. If there's snow on top of it or it's raining on top of it, well, then it's not going to do the spot. So that's kind of serpentinization is a reaction involving transformation of fayalite, Fe, which is iron, and member of an olivine by water into magnetite. Hey, get that magnetics, right? Hear the words? And quartz. Fault lines.
Yeah, and quartz. So, and that's what you mentioned earlier. Also produces.
Gold, you also have magnetite and quartz as well.
Right. Also produces molecular hydrogen, according to the fall react. Okay. And what our sun relates to us is helium and hydrogen. Okay, everybody, that's what it sends to us mainly. So there's a whole lot of things going on chemically in the rocks. That's why these geologists, when they study these rocks, it's like, oh, they're just boring. It's just rocks. There's a bigger story going on here. And if it's kind of like those people who don't like baseball, I get baseball's boring. It's because you don't understand the interplay between the pitcher, the catcher, and the batter. And then the other stuff is beyond that, but it's really those three and the interplay. It's like a game of chess. This geology is the same kind of thing. You got to push back the idea, it's always boring, it's just rocks. No, rocks actually are part of the whole system. And if you understand that and how it interacts with other rocks and the plausibility that, hey, maybe not the next day, but there's a big wildfire moves through here, like what's happening over there in Los Angeles. You know, what was been going on for, last summer? The big fires over there in Malibu. Well, guess what? There were several earthquakes there too. Hello? You know, it's like, hey, you know, oh, it always burns. Yeah, because there's serpentinite there. There's fault systems there, right? And there's, you know, this thrust and fold that's going on over there. And up in here in the Stanley area, there's thrust and fold happening up in here too. So I think adding each little piece together builds a larger picture to say, hey, wait a minute, these things are interoperating together, and it isn't just one item, but it's multiple items working together to create a larger picture of a larger system. And when you understand that system a little bit more and you study in it more, and it's like, wow, man, I just studied rocks. That's all I did.
Yeah.
Or I'm not studying rocks because they're boring. Brockhead. It's like, whatever.
So now what we're going to do next, we're going to go back to the quakes, and I'm going to show you.
Okay.
The pattern going all the way back to 1872, because that's when they started keeping track of fault quakes in Idaho.
All
so
right.
I'm going to put the study in for that because it's pretty good. Because I love my data lists.
Yes, you do, sir.
Gives me dates compared to other things. So
All righty.
It takes a bit to load too, so I'll see.
It does. I'm watching it work. It's a PDF file here.
Yeah.
It's a big PDF file.
Yeah. And what it is, it's basically a list of quakes starting in 1872 all the way to 1983. But it's good because I can use it.
Oh, 1872. We know what that date means in California.
Yeah. So it just so happens that was when they started keeping track of them, which is pretty good. And I'm going to point out a bunch of dates in this thing, and we're just going to scroll down through it because it's like
all right.
gigantic.
All right.
Yeah.
I'm ready for you.
So I'm going to start at 1872.
Okay, what page do you want to be on?
It's just like a big long table after you get past the, how many pages are there? 1, 2, 3. It's where I want to go.
Because it gives about 1,700 seismic events from December 10th, 72 to December 31st, 83.
Get down to where the big table thing is, whatever page.
All right, scrolling down, earthquake listing.
Yeah.
All right.
It starts with a date and it gives seismic intensity, and
all right,
it doesn't give a mag, but it's good enough.
Local intensity.
What's going on. Yeah. So the first one it talks about is December 1872.
Mm-hmm.
Well, guess when that was? That was the North Cascades earthquake, just above Nick's house.
Interesting. There's a date on that? I can look that up. North Cascades is what it's called.
Just look North Cascades quake. And we've talked about this before because it's
sure the frack is.
Owens Valley quake too, right?
Yeah. 1872 North Cascades occurred 942 December 14th, Washington Territory. Level 8 severe.
Look at the dates on the list, because you got to remember this is Idaho quakes.
Right.
So Idaho was shaken.
Yeah, and on the 10th and the 11th, and then that quake happened on the 14th.
See? Magic.
Yeah, magic.
And one was seismic intensity 6.
Yeah.
And the other one was 0, but they still felt it.
Mm-hmm.
Yeah. So then I started going down because I look at all the exciting numbers. So see, it was acting up in 1880. Because now we're getting into all the crazy San Francisco
earthquakes, yeah.
Yeah. 1884 was the same year as the New York City quake. So I said, well, this is interesting. It's like going both sides. So then 1893 was the big quake that was, well, no, it would have been the year after. 1892 was the big Baja quake. So,
well, there's an 1897 as well.
yeah,
and sure enough, there it is.
1899, that was when the big Alaska quakes were. So it was acting up that year in Idaho.
So Idaho breaks often.
Yep.
And I'm just going to summarize it here. By knowing these dates, you've studied these other earthquakes from Mexico to Alaska. What we're saying is the entire western part of North America's plate is moving at the same time.
Other big quakes. So, and now look at 1906.
1906 got three of them. Yeah, look at that. Bang, bang, bang. And the intensity is a 5. 1905 had an intensity as a 7. And 1906, a 5, a 5, and a 5.
That would have been a little bit before the 1905 one because it was in November.
And right. The San Francisco quake was January.
1906, April.
April? Okay. So 1906 happened after that, but the 1905 happened in November. Then the great San Francisco quake happened in April, 4 months later.
Yeah. And you can actually go and look that up because I just did a search and they said, people have reported it shaking in Idaho that whole year.
And I remember too that in hearing the reports of the 1906 quake, there were several aftershocks that shook the area for the next part of a year.
Yeah.
And so it's just one earthquake.
Salt Lake City felt the San Fran quake.
Yeah.
So that's pretty wild. So it went all the way across to Salt Lake City.
Well, they felt it beyond Denver. The earthquake in Southern Cal, the 7.3 in 1992, they felt that all the way across the United States, which was odd. Remember they said buildings swayed in Denver. And I want to say, I don't know about how far the furthest report was, but I was just beyond Denver. So seeing San Francisco or hearing of San Francisco's earthquake, and then people feeling that 8, which it was an 8, traverse across the United States, across the Great Divide, and to feel it in Denver again, that's pretty amazing in itself.
Yeah.
So
I'm going to keep going down through this list.
Go ahead.
I'm going to get some other dates when it was acting up. So see, I went down and I said, oh, there's a couple in 1918. Well, that's when the big San Jacinto quake was.
San Jacinto, 1918. Yeah. And a level 5 shaker. Yep. Intensity, so they don't have any.
Yeah. And I kept going down and I said, oh, well, look, there's 3 in 1925. Well, that's when the big Santa Barbara quake was. And it's also when the Helena, Montana quake was, which is on the same lineament going up into Montana.
Right.
So Montana, Santa Barbara, and Idaho.
And you got a level 8 shaker here. In 1925.
Yeah.
I mean, intensity of an 8.
That was the Montana quake up there because it came right down through, reverberated down the Willamette Great Falls tectonic zone right through Challis to Boise.
Crazy.
And Boise's biggest quake near it was in 1916. So when I looked up the history of quakes,
3 quakes there,
Yeah, so when you look, see there was a whole bunch of quakes, 15 and 16.
And 17, a couple in 18, a couple in 20. And then it started to mellow out, and then 25 was big. 26
And
went big. 28
yeah,
went real big.
yeah, in 1929 we had the big Lompoc quake.
So can you see what we're talking about, everybody? That when we see a quake, we try to research out where it came from, where that pressure is moving come from, and where it's going to. And that's why we call it a place of interest. We're not forecasting. We're saying it's a place of interest, and we're going to watch it. Some things you can say, well, it's just going to happen. But we don't know when. So it's like, oh, there's so many guys coming on the internet now with fancy ideas, and they're forecasting, and there so many are wrong. Oh, I've been doing this for 20 years. Follow me. Give me $10, $10.99 a month, and da 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 da. Well, yeah.
And so if you keep going down this list, because see, there was a whole bunch in 1930.
Ton.
And then it calmed down for a few years, but in between that, you had Long Beach.
10, 11, 12 earthquakes in 1930s.
Yeah. And in 34 is when you had the big ones in Nevada. So see, it was acting up then too up in Idaho. And so I just kept going.
One of those is 11. Two of them are 11 or 8 intensity of 8s. So that's pretty powerful earthquakes.
Yeah. So I kept going down, and then I got into the mid 40s, and I said, oh, well, yeah, that makes sense. Because, so see, it was all acting up in.
When was it? 44 was the Nankai trough. What was the date of it? What was the date?
44 and 46.
What was the date on the Nankai?
I think they're both Decembers.
Okay.
December. So
well, we got level 7 shaker here in 44. I see level. It's just an intensity level. Okay. Nothing more, because they're not putting magnitudes on these, and I can't. But
yeah, they just did it with seismic intensity, based upon felt reports from back then.
Yeah.
Because I don't think they had a seismo in Boise till, I think it said 1935. So in the records, they just recorded by what the felt reports were for seismic intensity on this. So, but it still works.
They start to get magnitudes. And what's this date here? 1930. Yeah. And they've got a 6.6, a 6, a 5 1/4, a 5 1/2, 6 1/4, a 6, 5 3/4, 5 1/4, 5 1/2, another 6. Idaho gets a bunch of 6s, man.
And
the 40s.
In 46,
30s.
we had all those crazy quakes going off. Puget Sound had a 6.3 in February on Valentine's Day. And then later on in June that year, there was a big quake on Vancouver Island, 7.3 in 46. So you can see that Idaho was acting up before.
Yeah, Idaho had a couple of 6s, yeah.
Yeah. And then
in 44, 45.
A little bit more in 47 and 48. And then it was going crazy in 49 when there was another 6+ in Puget Sound and the 8.1 in Haida Gwaii, the biggest quake recorded in Canada so far.
Right. And we're seeing intensity levels from an 8 from the 6 1/4 that happened in 47, late 47. And that quaked all the way into the 50s.
Yeah. So if you look in 52, see, it was acting up in Idaho in 52. Well, there's your Tehachapi quake.
Tehachapi.
Yeah.
Yep, there's a 7. They don't have a local intensity, but significant wave magnitude. They don't have it. They've since have shut that off or turned it off for some reason. Yep, 52, definitely.
So you keep going down, you see, look, it was going crazy in 56, 57, 58. Look at all the ones in 58.
Yeah,
59.
1958. Look at that. There's another one. 1, 2, 3,
Well,
4, 5, 6, 7, 8, 9,
1959 was Lake Hebgen.
15, 16,
So
17
Idaho
quakes
was
in
going
58.
batshit crazy before Lake Hebgen.
Yeah. 17 earthquakes in Idaho of one significant or another. And they're all on
And
the
look,
same
after Hebgen
longitude.
went off, look
The-
at all the 1959, because they were feeling all the aftershocks from Lake Hebgen.
Sure.
Yeah.
Massive amounts. Massive in the 1960s as well.
Then you get into 60. Well, that's when the big chili quake was. And look at all the ones that's still aftershocking up there in 60.
Right. We bring outside the United States in once in a while when we see a significant quake in um, primarily in Peru, Ecuador, and then the Middle America and up into Mexico.
Yeah.
Periodically, we will call a significant quake because of in 1962 was it? The big 9.5 or was it? I don't know. The largest quake in history.
That was 1960.
1960. Yeah.
Yeah, so
We'll call those out because those move the plates. They shift the wobble of our planet and our 22 degrees bend as well. The 8.0 that happened in Peru, scientists do believe that it changed the angle of our planet and partial of a degree. And you talking about a 9.5 in 1960. You talking about these major earthquakes, not just in the Western Hemisphere, but the Eastern Hemisphere as well. You have to understand it affects the entire planet.
Yeah.
And you get enough push and pull, and you get the tilt of the earth just, wobbling a little bit different or going greater than, I think it wobbles between 22 and 24 degrees. Not wobbles, but it spins. You talk about just the 2-degree difference there. Do you think that has anything to do with global warming? Do you think that has anything to do with the way the storms are on the earth? One side getting a little hotter than the other side? Very well could. Natural occurrence. Oh, but it's man. Man's farting and dying, cows farting. I got a neighbor. That's what he thinks. It's the cow farting. Dude. What about dinosaurs, dude? What about the dinosaurs, man? They're crapping all over the place, and they're bigger.
Cows would be farting more if they're
no, man.
Idaho with all these.
Today, the CO2 levels are way higher than any other time in the history of the world.
Well,
I'm telling you, one dinosaur would crap. I told him the other day, I said, one dinosaur will crap more than you will in 10 years. What you do is take one turd. Wildfires, yeah, they were swamped. The atmosphere was thicker with moisture, and oh my gosh, whatever.
Because they said that this was the Quebec fires.
23.5 degrees of a tilt, yes. Well,
yeah, the wildfires in Quebec put enough carbon into the atmosphere that it was like, I think they said 10 years of all the cars we use on planet Earth.
Yeah.
In like a few months.
Yeah, it's like, oh my
crazy.
God.
So
give it a Tums. 1960 was the magnitude 9.5. Thank you, brother.
Yeah. So if you keep going down through this list, it keeps showing them it's going batshit crazy. 61, 62, 63.
Crazy.
Into our big Alaska quake in 64. So Idaho was going batshit crazy before.
63 is insane.
Yeah, that's why, because it was going off. Because if you extend the liniment lines up there that we're going to talk about, guess where they go? Alaska.
All right.
When the big 9 point whatever, 9.1, 9.2, 1964 Alaska. So Idaho was going batshit crazy before that too. So if you see Idaho going batshit crazy, look out. That's the moral of the story. So I just saw this when I was looking through 64, but I kept going because it was going crazy all through 64.
Shit, 71 as well. That's when I'm looking at Somar quake.
Yeah.
A lot. Unfortunately, don't have magnitudes. They have depths. In 1971, Somar quake, which was in Southern Cal. Yeah, there's every bit of 20, 30, 40 of them. That's crazy.
Yeah, in 68, there was another, that was the Borrego Springs quake on San Jacinto.
Right.
So it was going batshit crazy.
So and I'm going to stop you here. So what you've done is you put up a supposition, an idea that one area gets quakes during or before or after another area gets a significant quake.
Yeah.
That the area of the significant quake didn't just happen in a vacuum, meaning it just didn't happen out of freaking, random.
Yeah.
That's the vacuum that I'm talking about, the vacuum between somebody's freaking ears.
And because Idaho is the old North American plate boundary.
Plate boundary, yeah.
It should shake.
That's the Intermontane, right? Prior to the Intermontane, the border of North America was somewhere in Idaho where the ocean was to Idaho. All the land west of that was accreted. In 1952 was a magnitude 9 somewhere. Okay. Accreted igneous provinces, which are islands or island chains or uplift because of North America smashing into the ocean plate, whatever was out there, whether you want to call it Juan de Fuca or part of the Pacific that broke or whatever, doesn't matter. But it's accreted. Something accreted means it joined and came above the water and became partial of land. And as all of that happened, and you have to listen to all of our other rabbit holes to really see that much of it came from the south, moving on north, all the way up into Alaska. That's where you get all those weird mountain ranges in the Bay of Alaska, where the plate has subducted down below, meaning one plate rises up on top of another plate. And the one that's dropping down snaps and then continues down below, or gets shoved down well below and it gets burned up or what's sifted, so to speak. It takes what's buoyant and rises to the surface, and then what's condensed, it just keeps sinking down. And there's people who've taken images. Not like we would take pictures of ourselves, but they've taken images of sound waves bouncing off rocks, and they've have learned to read the sound waves and earthquake waves that go below to differentiate between water and this kind of stone and this kind of object, to be able to differentiate what they're seeing down there. 30 miles, 40 miles, 50 miles, 100 miles. Into the surface or below the surface of the earth, so that they can make the supposition. It's a educated guess on what's down there and how the plates have sunk and then uplifted. You got one that's kind of going like this, one's going like this. They're going to crunch, and as it's crunching, it's going to rise up and above the water. And that's kind of what's happened in the whole entire West. And also volcanic activity. Magma rises to the surface and spreading out masses amount, 3 miles thick of some stuff, 6 miles in others, where so much magma's come up and it's made land, kind of like how islands are made. And all these kind of things were accreted, brought on, and become part of North America, right up to that boundary here, the Idaho batholith, which is volcanic. And it's interesting how all these things come together. And different kinds of rocks move at different speeds. Different kinds of rocks break at different speeds and break differently, and or melt at different rates, and slide differently, move differently, and the shapes affect all that. And then put a little water or a little snow or a little ice, that tends to act on the rocks and the land differently too. Then you've got storms and erosion and moving stuff around, and all of that's part of our earth that we live on today. So that's why these things are important. That's why this in-depth study kind of helps us see and peer into the unknown. We didn't live there. We weren't born then. But
and I just want to finish summarizing this list.
Okay, go ahead. Go with your last point there.
83. So as you keep going down, you'll see that it was going crazy 81, 82, and 83 before Bora Peak had the big one. What we talked about earlier.
I'm going to check out 1980 here first. Yeah. Look at 1980. Boom, 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 boom.
Which is the same as Mount St. Helens.
Boom, 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 boom. Yeah, Mount St. Helens was going crazy.
And now I'm going to explain why, because we're going to do the two lineaments.
Okay. All right.
So we're going to do Al first. I need to bring that up.
Let me refresh this. Just want to take a quick look what's going on. These are seismos that are going on. Looks like Pecos, Texas has a pretty good one right now. Felton, Oklahoma. So that's another Texas, earthquake. All right. So you've got another link for me?
Yeah, I'm going to put the Olympic Wallowa one in next. And then I'm going to explain it.
Olympic Wallowa. There we go.
There's a map in it too. So.
All right, I'll find the map and I'll let you run it. Oh my God, it's so. Now how are they gonna read that? Come on, God. Is the owl an optical illusion? I don't think so. Yeah, it's not. I can't.
Is it gonna let you?
All right, let me. No, it won't let me. I'm gonna take a picture of it and try to increase it size.
We used that map one other time.
I don't know why it won't blow up.
Fault lines in Oregon, I have to find it again. And Washington.
It's all right. That's all right, bud. I'll blow this one up. All right, I got it blown up here. Let me.
It won't let me make it bigger either.
Yeah, I know. Let me get over here where we are, and share it. Hide. Share it. What? Screen. Window. This one. Share. Da 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 da. All right. What the hell happened? Screen. Share. Oh, that's the wrong one. All right. Share.
Yeah, Luke is asking,
Screen.
the 706 line, Western Idaho shear zone are the same thing.
Yeah.
So the question,
I'm not sure about that, but if you are, then yeah, thank you. I was going to ask you that question too.
Yeah.
All right. So zooming in here.
Together. Yeah. Because the 706.
Right, this is your image. So
boundary of North America.
Right. Go ahead and talk about this Olympic Walla Walla.
Yeah. So I'm just going to
lineament.
Read the first part of it and then explain it more. I'm going to go back on my screen. Because now I got the map up in my way. There. So anyway, so we're going to read about it. The Olympic Wallowa Lineament is a series of geological structures oriented from northwest to southeast for 650 kilometers, 400 miles across Washington and northeast Oregon in the United States, passing through the Seattle area and including notable features east of the Cascade Range, such as the Yakima Fold Belt and the Wallowa Mountains. So the Yakima Fold Belt is what goes right past Nick's house,
Okay.
which he's been talking about in the latest
Yeah,
things.
in classes. Yeah, in class.
Yeah, it was first reported by cartographer Irwin Raz or Raz, I don't know, in 1945 on a relief map of the continental United States. Some geologists have questioned the existence of a geological relationship between the individual structures along the lineament, suggesting it is an optical illusion. The origin of this feature in its entirety is not well understood, and multiple hypotheses on the subject. The Olympic Wallowa Lineament likely predates the Columbia River basalt group. Well, yeah.
Well,
But that's besides the point. And Nick's been talking about that in his things.
yes.
And the new
For
thrust
hold on, for those people who are on YouTube and on Rumble, Nick Zentner, he's a teacher in Washington University, Central Washington University, who teaches geology, and he puts on a class where he gets a lot of articles, such as what we're doing, and synthesize. And that's such a terrible word, but brings it all together and presents it to an easier way to understand. And also, he gets the top geologist in the discussions and interviews them, and we get to peer into what modern geologists are thinking through all their studies, and we get to glean from them in a rich way. So look, Nick Zentner, it's Zentner on YouTube. He's also at Washington Central University. You went Central Washington University, CWU. Yeah. You can find him there too.
So now they're going to go into detail here on the location, so it's going to make more sense. So they're saying exactly where it goes. Ray located the owl, particularly from Cape Flattery, the northwest corner of the Olympic Peninsula, and along the north shore of Lake Crescent, thence the Little River, south of Port Angeles, Liberty Bay, Elliott Bay, setting the orientation of the streets in downtown Seattle. So I thought that was funny that the streets go at the same angle as the lineament. The north shore of Mercer Island, the Cedar River, where the Chester Morse Reservoir is, Stampede Pass, which is at Cascade Crest, and the south side of the Kittitas Valley, which is where Ellensburg is, so Nick's house, Manistash Ridge, which he's talked about that one a bunch of times, the Wallula Gap on the Columbia River, where it approaches the Oregon state line, and then the South Fork of the Walla Walla River into the northeast corner of Oregon. After crossing the Blue Mountains, Riaz associated the owl with the dramatic scarp on the north side of the Wallowa Mountains. Riaz observed that the owl tends to have basins on the north side, Seattle Basin, Kittitas Valley, Pasco Basin, Walla Walla Basin, and mountains on the southern side, the Olympics, Anastash, Umtanum, and Rattlesnake Mountain, the Horse Heaven Hills, and Wallowa Mountains, and noted parallel alignments at various points, generally about 4 miles north or south of the main line. The alignment of these particular features is somewhat irregular. Modern maps with much more detail show a broad zone of more regular alignments. Subsequent geological investigations have suggested various refinements and adjustments. So the last big study they did on Owl was 2021, and I can't get access to it, but it's like gigantic. And
Looks like to me it goes right to Denver, or just south of Denver, in Aurora. If I
yeah, it would
continue,
go
go
across,
right through
yeah,
Rock Springs.
through all that stuff,
Yeah.
on that same angle. And
Right.
now they found like all the thrust faults that are near Nick. Because just in the last few years, they've been trying to find all them with LiDAR.
Right. And that's what I got out of his classes this last 2 weeks. These up and down, up and down, up and down.
And they're northwest to southeast.
Thrust faults.
Same as the Owl.
Right.
Because I believe the Owl is what made them in the first place. Anyway, coming up, the core.
Yeah. Yeah, the push from the south, making these things roll over on top of each other right in Ellensburg, south of Ellensburg. Yeah.
And then it goes on. It talks about how it intersects all these other fault zones that we talked about before when we were doing Washington, Oregon. So it's talking about the Brothers Fault Zone and all that stuff, and it says like how it's going across and intersecting all these other ones that are either going the same way or the opposite way. Now the opposite way is when we do the next one.
Okay, so go ahead and let's move on from here.
Yeah.
And let's go to the next lineament.
Yeah. So the next one we're going to do is the Great Falls Tectonic Zone. So I'm going to bring up the one for that.
No wiki on that. Wiki is just a way that we use to access information. Good evening, Vampy. Good evening, Thunder. That's exactly where I live. Waves hi to everybody.
Yep. So there's all sorts happening places. All this stuff.
Now the orientation of this this one is a little bit different. Yeah.
So I'm going to bring it up. And
there we go.
It'll start making sense.
So looking at the map here, you can see the width of this lineament, roughly almost maybe just under a quarter. It's well under a third. So of Montana. Okay, crossing the Rockies, and it's probably a couple hundred miles wide. And this is a tectonic zone that exists that scientists have said this area is significant. And for us, we see it going, as science would say, it doesn't stop at the border, but it continues. So we constantly say we look beyond them and go all around the planet, because we think the Great Falls Tectonic Zone actually emanates from the core like a laser upwards.
Yeah, all the lineaments go around the whole planet.
Yeah.
That's what the neotectonics people say.
Yeah.
So they go, once you find one, you just keep going by how it trends, and it can take you the whole way around the world.
The Great Falls Tectonic Zone is a major intercontinental shear zone between the Harney Craton and the Wyoming Craton basement rock of the Archean Eon, which is the part of the North American continent. The zone is an area of about 100 miles wide, extending from the southwestern Idaho-Montana border across Montana to the northwestern Montana-Saskatchewan, North Dakota border. It is named for the Great Falls of the Missouri River, a major geologic feature of the area. The central and western portions of the zone are believed to be about 1.1 to 3.3 billion years old. The central part of the zone lacks Archean rock. However, leading to the least one group of scientists to speculate that it was formed very late in the Paleoproterozoic era. Yeah, that's kind of crazy that it just all of a sudden happened. Didn't happen before, but it didn't. Yeah. So there's the rocks itself, these missing rocks that's why they say, oh, hey, this thing might be younger than it is. The Great Falls tectonic zone has been periodically active since the Proterozoic and possibly as late as the
Oh yeah,
Holocene.
it's active today and it's been active forever.
Yeah. Little of the zone is visible due to Phanerozoic cover, the exception being the Little Belt Mountains. However, it is believed that the tectonic zone controls the geologic development of nearby basin and subbasins. The Great Falls tectonic zone was identified in 85. Geologists originally believed the zone was part of the Wyoming Craton, but now conclude that it is distinct from the Wyoming Craton. There is a continued controversy over whether the region is a shear zone or a suture. I think we need to define what those are. Structural or suture is a joining along a major fault zone of separate terrains, tectonic units that have different plate tectonic, metaphoric, and paleographic histories. The suture is often represented as a surface by an origin or a mountain range, whereas a shear zone is a geologic shear zone is a thin zone within the Earth's crust or upper mantle that has been strongly deformed due to the walls of the rock on either side of the zone slipping past each other. The upper crust, where the rock is brittle, the shear zone takes form of a fracture called a fault. In the lower crust, it does something else. Now I have to go all the way to it. In the lower crust of the mantle, extreme conditions of pressure and temperature make the rock ductile. That is, the rock is capable of slowly deforming without fracture, like hot metal being worked by a blacksmith. So that's interesting. So the two different things, a suture and a shear zone. The shear zone bends the rocks without actually creating a fault, whereas the other one is basically fault oriented. So there you have it.
If you read the newest stuff on it, it says it officially goes from Boise, Idaho through Chalice, going on up through Montana near Helena or Helena, however they say it, which there's been big quakes there in the past in Montana, going right on up through into central Saskatchewan. And that's as far as they take it. Well, if you follow it up and go on the same line, it goes between Regina and Saskatoon, and if you keep going, it ends up at the Bay of Churchill, Manitoba. And if you look where the fires are now, you can follow it right up that line, and you can see there's fires on either side of it the further you go up, because they had to evacuate Flin Flon, which is a big mining area.
Up in Canada.
Yeah.
Well, there's also controversy over whether or not it's a shear zone or a suture, and the role of the zone played in the formation of North American continent. At least one time, both the Great Falls tectonic and the Vulcan structure were both considered sutures, but debate remains open to the point. At least one group of geologists has concluded that zone represents a closure of an ocean basin. The zone lacks gravity anomalies or electromagnetic signatures, which would allow scientists to conclude it was generated by a subduction. There are significant evidence that the zone has been periodically remineralized since the Precambrian time. Square Butte, Shaw Butte, Crown Butte, and other structures of the Idaho Mountains volcanic field lie astride the tectonic zone near the city of Great Falls. So what they're saying is as the electromagnetic anomalies dissipate, it regenerates, making through volcanic activity and re-energizes that same line. So it might be super ancient, where it lost its ability and then regenerates itself again.
Extended out, it basically goes from Mendocino to Svalbard.
Okay.
What I did to trace it across North America.
So it's quite wide, and as we're looking at the Great Falls, you can see right here, okay, from that edge straight at an angle here. Where's the edge? Oh, right here from this edge. It's in the middle. It's just above it, just there. So we take it. You guys find this. Oh, right here. All right. So it's this way.
Yeah. So
that's basically the line. So if I took this line, drew it out like that, right? And I did backwards the same way.
Yeah. So I'm primarily concerned with North America. So that's when I figured it out. That's what I was focusing on. So you have it going.
Right. So because of the curvature of the earth, okay. So this is what he's saying. Yeah, this is what he's saying. Right where's Stanley? I think Stanley's right in here.
Stanley in that area would be where the two are intersecting. Yeah.
Correct. X marks the spot. So just by Missoula, right? And then you see down here the Walla Walla. So the Walla Walla crisscrosses the other zone about right here. And this one comes all the way to be Neha Bay. All right. So you can see this is the crisscross right through here. And we can look up here in the Chalice. There's Clearwater. That's Missoula. Wallace. Oh, I can't even find it right now.
Yeah. So when they located the big quakes, both in 2020 and 1983, they basically located them like out of Chalice, where that seismo was. If you look them all up, and they all refer to them as Chalice. So Chalice is like right on that Great Falls tectonic zone minimum. And you can actually go and look up all the faults that are there too, because I've done all this because I wanted to see how they were orientated, and they all match the
right
talking about.
Whatever.
And it runs.
And if you can draw a crisscross right out here, basically it crisscrosses on the border of this Walla Walla Mountains, just east of it. Where's that place in Washington that everything spins around? Is it west of Spokane?
Well, basically this whole area is spinning where these.
Yeah, but there's a point that doesn't spin.
Yeah, I can't remember exactly where it is.
Yeah, I don't remember where it is. But I was just wondering how close to the crisscross is that area?
Pretty close, because it's like the whole Great Basin.
Yeah. In Washington. Yeah.
Yeah, it would be all the way up past this.
Right.
And then all the way down to the bottom of the basin, which is all the way.
Yeah, this region is where it crisscrosses, where Washington, Idaho, and Oregon all come together in this region here. So this is where the crisscross happens. I didn't understand what he wrote. Yeah. Connect didn't mean it. He's got to pay more.
Yeah, so it's crazy stuff.
So yeah. So how do we wrap it up? We have two tectonic zones, one crisscross, one's ancient, the ancient boundary. Maybe it's three of them. The ancient boundary north-south of North America. Then the accretionary stuff of the intermontane and the other ones that later came in. And we got the Walla Walla. It leads to the Walla Walla as it came in. I wonder if the orientation, I'm just thinking out loud, really. You see, did I close it? I think no, I didn't. Here we go. What's right
well,
here?
think about how North
Okay.
America's moving.
There it
That's
is.
why it's spinning stuff.
Yeah, that's what I kind of was after. So if our line was here, and now the orientation is here, there's a difference of 300 miles, and it just so happens that's the northern part of the Juan de Fuca that's not active. We have the volcano that's in the middle of it, the hot spot.
Yeah.
I wonder, just here we have the hot spot here, and there's the hot spot there. That's kind of in the middle of it all too, isn't it?
Yeah.
And
I think of the Snake River Plain going to San Francisco. So if you want to make the Snake River Plain another liniment, see, it's all that same angle. It's all the same angle. Right?
Yeah, I mean, Snake River being right here, you're saying it kind of goes to San Francisco. Yeah. If you straighten it out, because it's all bent to hell, that.
Yeah, it's all bent from the rotation. But if it was straight, which is what they talk about trying to figure out where the Yellowstone hotspot was, right? They
Correct.
Take the rotation back to get it straight.
Yeah, they got to move the Mendocino substantially south to down here to Los Angeles or even San Diego. So this line here is somewhere down here when that stuff starts to happen, because there's.
And I think Mendocino to Virginia is another east-west liniment.
There's your 1,000 miles. There's your 1,000 miles for. That would be the point of Baja. That's very, very interesting.
1906 San Fran quake, because it reverberated along.
We had this one to. What was it? 3,000 miles. Oh, it was 3,000 miles. I thought it was only 1,000 miles.
So it's like crazy.
Oh, no. Sorry.
Well, they're all long. Like if you keep going.
Yeah, 1,000 miles here. So I'm wondering if that 1,000 miles matches the Mendocino, right? Coming down here, that's 1,000 miles, right? Because everything moved north. And then, the liniment, the old liniment, which is what we just discussed today, basically what the Walla Walla went right through there.
So that's why it's spinning around, because you got all the movement and
right.
coming at it from the different ways, and it's spinning
around. Yeah, right. And then this one,
which they can see in all the GPS stuff now, right? But I believe it's still the liniments that are moving everything, and that's what has always moved it.
Well, is it the liniments that's moving it, or are they moving along the liniments?
Well, I think it's.
So you gotta ask that question.
Because the quakes are all along these same lines. Quakes are the plates moving.
Well, I get you. Wow, look at that. That would be interesting.
So to me, it's actually the liniments that are moving everything. That's why when you go back and they get into the cratons that they're talking about here, the different cratons. So they're saying North America's made up of all these other cratons that moved and hit together. And that's where they get the suture zone, shear zone thing. But they're still, I think, moving all along the liniments. And you can go anywhere and look all this stuff up, and you'll find out it's the same thing.
Mm-hmm.
All these various pieces of cratons are all smashing together. And that's what it's doing. And I think that's what's moving it. And you'll find the rift zones match, the mountain ranges match, the hotspot tracks match, where the asteroids hit match, where the faults are and the fires love to go. It's all magic. It's just because we haven't been paying attention, but now we have the data to do all this stuff. So we can watch quakes, wildfires.
Yeah, the Klamath Blue Mountain liniment, slightly misplaced. That can be.
like on Google Earth when you start looking for these things. You just don't know what to
Right.
call it. And then
Right.
you got to find out, well, they found part of it and then they give it a name. But because it doesn't care if it goes the whole way around the world, then I don't know what you call it. Whatever.
I don't either.
Yeah, whatever name. In some of the new stuff I've seen, they give it like a number. They say whatever with a number. And they say this one goes the whole way around the world. TB1 or
all right, so do us all a favor. Summarize what you think the best way for you to say within a few sentences without going into the data again. Summarize what it is that you're really trying to say in regards to the study we've done tonight and your best approach. What is it you think people should take from our little study today?
Well, to simplify, if Idaho starts swarming with a whole bunch of little quakes, like 2s, 3s, 4s, 5s, and if it jumps up into a big one, like a 6 or bigger, get ready for all sorts of trouble on the West Coast. Because apparently that's what it does if you look at the data.
Yeah.
So now we wait. And my guess is, my guess based upon what the Texas Lineament's doing, what the Owl's doing, what the Great Falls Tectonic Zone is doing, we should get a bigger quake. So I'm saying 6+, anywhere probably from San Fran up to
Vancouver
pretty soon.
Yeah.
Which pretty soon could be within a year, but I think it's going to be here quicker than that based on what it's doing.
Right. Well, Texas went tonight. I'm going to see what the USGS has to say about it.
Texas had a 5. When was that? Last month, too? I think it was last month.
Well, shit, it was in Mexico. Dude, didn't I just talk about that the other day in the morning report? I said, looks like 1887 all over again. South of Chihuahua. This wasn't in Texas. It was in Mexico.
That's the other one that goes northwest and southeast. That's the next one down from Texas.
Yeah.
Sonora.
Now for those who don't know,
they call it the Mojave Sonora Mega Shear Zone, but it's another northwest to southeast.
Well, this is on the backside. Yeah, it's on the backside of the Occidental. So it's we just had an earthquake there not too long ago. Last week, I think. And Panama had a 5.7, right? And that, if you take that line, your show on stream, take that line to the Panamanian quake, and then you have off of Oaxaca here is a 4.2. But take this one, drive it to this one, and watch. Where are we going? Right to Stanley on this map.
Yeah, and that would be your Strontium 706 line too, if you come down, I think.
Mm-hmm.
But they only take that down.
Not talking about the Mexico quake, but talking about this one here, and this one here. Straight line. That's interesting, everybody. That would suggest
the Panama 5.7 would also be coming up Walker Lane too.
Yeah.
Or my angle for Walker Lane.
Well, we do have a Los Angeles quake. It's a 3.2 in Idlewild. I think maybe somebody felt that. Tres Pinos in Central Cali, 2.6, and 2.7 Petrolia today along the coast. That's along the Pacific Plate boundary that's hitting North America. But these internal North American quakes, we also had one near the Hebgen Lake tonight at a 2.7.
Yeah, I heard us talking.
Yep. Very, very, very interesting, and we can go rabbit holing on that for a long time more. But I wanted to summarize what he's Canuck is talking about. Showing a history of the Stanley or Central Idaho quakes, not just only the Stanley, but also the larger one, the 7.1 that happened in 83, and the history of all the sixes since the 40s. And we went back into the 1800s and said, wow, this area has been activated, whether large or small, but has been activated. It is part of something that is showing evidence of other things and other quakes along from British Columbia all the way down into Mexico, events that have gone on. And we've also studied Baja to BC, which ended in some circles, some 48 million years ago, and it's all in Canada. However, since the accretion of Silesia into California, Washington, and Oregon, that accretion, the last accretionary province that came in, the belief was that Baja to BC died. But I think the more studies that go on, it's not dead. Why? Because Baja to BC has to do with the Pacific Ocean moving north and North America moving southwest and crashing into it and getting buzzed, like he wanted to say the buzzsaw, right, on some of his stuff. Well, in a larger sense, North America moving at southwest, hitting the Pacific Ocean, and it's just grinding away, such as Baja used to be part of Mexico, is no longer part of Mexico, but it's now part of the Pacific Ocean moving north. It's very, very interesting on all these things. The 1887 story was the first rabbit hole we had here on in part of the Joe Slick Studios, and it talked about how Wyatt Earp's doctor took leave and went down into Mexico to find out where the hell this thing happened. And the Mexican government also sent a group of military personnel north to find out what happened. And they met in a little town not far from the location of this quake itself. And you can look that up. And at that time, quakes were happening eastern Texas. But since that quake happened, it's now all happening in western Texas. And that's my observation. And if you want to look it up, go right ahead. Feel free.
Yeah, and the Charleston quake happened the year before, 1886 and 1884, was the New York City quake.
Yeah, but since that Mexico quake, something changed in the tectonic pressure, and that's where we're at now. Now, maybe this stuff was happening before 1810, 1811. I don't know. But those significant events, maybe it's not going to be New Madrid anymore. Maybe it's going to be west or east.
Texas were reporting shaking in Texas in 86, right after Charleston as well.
Very, very, very strong, yeah.
So that was before 1887.
Again, we're looking up older earthquakes to try to understand the current earthquakes. And we're trying to look up the historical events to try to understand what's going on today and to see the reoccurrence of these patterns. They don't happen in a vacuum. This is the function. And it doesn't make it as scary for us because we're studying them and we understand, oh, well, that's just this. If you're prone to an earthquake area and it makes you afraid, well, primarily, most of the time, earthquakes don't kill people. Buildings or objects such as a mountain slide or something kill people. So if you feel you're in a building that's not capable of handling a larger earthquake, then do yourself a favor and move. get out of that building, or get into a 1-story building where, you know, you have that way to survive. If you're in a flood zone, get out of the flood zone. You know, do yourself a favor, you know, have a plan. Tell your family members that are all over the place, or if you're all together, it's one thing. Have a plan. Put money aside, even if it's $5 a week. All right. Food. Have freeze-dried food. Have water. You know, 50 gallons of water set aside. Well, it's a lot of space. Well, guess what? The number one commodity that you'll have and need of is water. You can do without food for weeks. You can't do without water for more than 5 days. So think about it. What's the most important? Also have something to protect yourself, something to purify water. Water purifier. They got the straws. They have the pumps. All that stuff's not expensive. Don't go to Starbucks for a week. You can buy all the food you need because, you know, Starbucks is expensive, not cheap. Every coffee's like $5, $6, $7. You know, just don't go to Starbucks for a month. You give yourself a whole month worth of food. I got 25 years food. I have enough food for my family for 6 months. I've had it since 2014 because it's what I do. I plan ahead. Do yourself a favor. Do that for you and your family, especially if you love your kids. Plan ahead. Plan for a rainy day, right? You have savings accounts. Think of this as a savings account. It's saving your ass. Anyway, do you have anything you want to close with there, Canuck?
No, that's it.
I appreciate what you did tonight. You really exposed some interesting things. I don't think many people would have put together what you were discovering there. The Pitone is kind of rumbling right now too. Well,
to me,
that's off Africa.
It just makes sense because it's the old plate boundary of North America. So you would think it would move in Idaho before it does anywhere on the West Coast, Alaska, California. Right. So
right.
Because it's moving all across the plate.
Sure does, doesn't it?
That's the big movement on the West Coast, which is what I'm primarily concerned with. I want to figure out when the bigger ones are going to happen on the West Coast.
Right.
Now, that is
all right, everybody. Thank you.
Bigger ones inland too.
We're right at 2 hours. Thank you, Canuck. I always appreciate you. Your dedication to studying the deeper things. I love it because you keep me kind of balanced a little bit because I'm a little bit out there at times. But I'm not trying to get anything on me. And for those who don't know, don't get none on you. Love y'all. And we'll see you next time on The Rabbit Hole. Appreciate you. Love you, Canuck. Thank you, buddy. And have a good night.